Oh, the classic mute. Welcome everybody to the Make Azure AI Real, the first of our series. So whether you knew this or not, this is a part of a series. Today we're going to talk about computer vision. We're going to talk about Florence model. We're going to really talk about not just talking about AI, but doing AI. That's what this series is about. And we have one of the best people to talk about AI and do AI, Carlota. How are you doing?
Thank you, Corey. I'm doing very well. I'm very excited to kick off this amazing series and welcome everybody. Thank you for joining us today.
So, everyone, thanks for joining. I have a question for the audience, and trust me, this is going to be really relevant later on. But I want to know what your favorite fruit is. So, I see a few people in the chat already. But yeah, tell us what's your favorite fruit. Carlota, I'll ask you. What is your favorite fruit?
Yeah, it's an easy one, watermelon.
Watermelon. Oh wow.
Yeah,
Okay.
so fresh.
Yeah, it's very fresh, but sometimes tasteless. I don't know. I'm not a big fan. I'm not a big fan, but
No, come on, it's sweet. You
yeah.
should taste Italian watermelon. Come on.
Yeah, I see Basti CL has taken my answer, which I'm completely cool with. But pineapple is probably my favorite. But a close second is kiwi. So it's like it depends on the day, depends on the mood, and it's so lovely that I live in Sweden where there's none of that grown. So it's always a bit pricey as well.
Yeah, the important thing is that you don't eat pineapple on pizza, please.
Yeah. Okay. Yeah. That's against the rules.
Just separate the two things, and then pineapple is good. Yeah.
Tune in later for our debate on pineapple on pizza. But today we're not going to talk about that. We're going to talk about computer vision and making Azure AI real. So tell us, Carlota, what is AI real? What does making Azure AI real mean to you?
So making AI real to me really means build a solution that integrates AI, because AI can unlock new scenarios, and in particular generative AI models are demonstrating that we can really address new challenges with using it. So I think it's the right time to test and experiment with generative AI and integrating it in our solutions.
It is the right time to talk about it. It's super exciting to see people again applying things that we've been talking about for years. And this whole series, it's a 6-part series, and the only constant, I don't know, someone thought it'd be a good idea to have me host this whole thing. So if you are joining today,
It is.
yeah, if you are joining today, please join us even next week. We have another session, and we're going to cover all these different aspects of AI, even responsible AI. So we're talking about applying it, but how do we apply it responsibly? So we're going to take the journey, and you're going to take it with me. So I hope to see everyone also again next week. But this week we're talking about computer vision. So Carlo, to kick us off, let's see, what is the world of computer vision? What's the update for us?
Sure, I'm happy to kick this off. So today, as Corey mentioned, we are going to focus on computer vision, and in particular, we are going to see Azure AI services capabilities. We are going to put these in action, and we're going also to see how generative AI enhanced not only the natural language processing domain that we are speaking a lot those days, but also the computer vision domain. So something I want to say before we kick off is that we want this to be as interactive as possible. So we have an open chat. Please comment and ask your questions whenever you'd like. I'll try to address them throughout the session.
You can definitely continue to put in your favorite fruits as well. So what is your favorite fruit? This again, very relevant later on. Trust me.
Awesome. So let's move to the learning objective for today. So we are going to understand how generative AI enhanced computer vision service, in particular with a focus on Azure and Azure services. We're going to explore Azure AI vision capabilities, and we are going to use Vision Studio, which is like the portal for accessing with the graphical user interface Azure AI vision services. We are going to use Vision Studio to address a real-world use case that will be involving fruits, as we have spoiled at the
spoiler
beginning.
alert. That is a massive spoiler alert.
Great. So let's start with what is computer vision. So I want to just give a short definition since we are going to talk about computer vision throughout the whole session. So computer vision is a core area of artificial intelligence, of course, and this is focused on understanding the information contained within visual data sources, such as images and videos. And this branch of AI aims to emulate the human visual perception by using advanced algorithms to recognize the content and context of optical input. So to an AI application, an image is just like an array of pixel values. These numeric values can be used as features to train machine learning models that make predictions about the image and its content. However, training this kind of machine learning models from scratch can be very time intensive and require also large amount of data. And there's where a service like Azure AI service become very helpful, because within the AI services offered on Azure, there's a service called Azure AI Vision which gives you access to pre-trained computer vision capabilities.
I really like this visual. It really, no pun intended, shows really a good visual of what the actual model is understanding, right? I mean, it'd be really stressful if you had to see all these numbers and arrays as we do. But to your point, right, it's super exciting that we don't have to like build these huge models now or huge data sets and train them and label them. Like that's all fun, but take us away about like how can we get this out of the box? How can we get started?
Yeah, and this probably is also helpful to grasp how machine thinks and understand the world, right? They think different from for us. So they think with numbers because they are like based on machine learning algorithms at the end of the day. So cool. So let's move to, we say that we want to do AI, right? So let's introduce computer vision applications. So we say that computer vision aims to allow computers to gain understanding of digital images. But what does it mean to understand in this case? Potential use cases for computer vision pre-trained AI models are represented here in this slide. We have, for example, description and tag generation. So determining an appropriate caption for an image and identifying relevant tags that can be used as keywords to indicate its subject. Then we have, for example, category identification. So identifying an appropriate categorization for the image. And for example, if it contains any known landmarks or celebrities. We have object, face, or brand detection. So the capability of detecting the presence and location of specific objects or human faces or brand logos within the image. We have optical character recognition, which is basically extracting text from the image. And we have spatial analysis, which is the capabilities of identifying people or objects such as cars in a space and map their movement within that space. So we're talking about video streaming, analysis of video streaming rather than static images. So these are some examples of applications of computer vision.
I mean, I like how you're running with the "Don't talk, do AI" slogan I just made up on this intro. So I'm going to run with it for this whole series. But I really like these examples here, and like, if you will allow me to like get on my AI storytelling seat for a little bit, like, I think one of the most interesting use cases I think I've seen with the computer vision, at least like how to apply it to help people. I was definitely, if you've heard of like that Be My Eyes company. Yeah, Danish company. So shout out Scandinavia, if there's any Scandinavians in the chat. But that's super cool, right? To help people who are vision impaired actually see things using the model. So they originally had, human volunteers, and now they've kind of complementarily put a computer vision model in there to enable even to help more people. So I think that's awesome. But to give you the boring story, well, not boring, but I worked on one project and it was like a parking lot, and they set up a security camera, and they just wanted to know if like a car was there or not a car there, because they have like, people watching the parking spaces. And if they saw like, this is some activity that like, oh wow, there's a lot more cars than normal, then they would send someone to that parking garage to like, be the security for that bit. But yeah, not as interesting, I guess, but computer vision nonetheless. All right.
Yeah, but I mean, useful, and security is definitely one of the most common application of computer vision. So great example.
We have a specific question. I don't know, Carla, if you want to take it now, or if you want to take it later on when we actually show or do AI. But it's around caption generation. So Valentina has asked, and maybe you'll show this later as well. Does the caption generation work with PNG and SVG files, or are there any limitations?
Yeah, so this works for sure with PNG file. I'm not sure about SVG. I will double check on the official doc, and we can send you the link to the official doc. But as Corey mentioned, we are going to do some practical examples. So I will be showing you how caption work later on.
Great question, Valentina. Great question.
Awesome. So I will move to Azure AI Vision service right now. So we say that Azure AI Vision enable or unlock the capabilities and the applications we just talked about. And to get started with it, again, we will see these in practice, but you need to provision a computer vision or cognitive services type of resource. And you can provision computer vision as a single service resource, or you can use the computer vision API in a multiple service cognitive services resource, depending on whether you need to use a single service into your solution, or if you need to integrate maybe and combining multiple cognitive services. And then you can rely on the Vision Studio UI, which provides you with a platform to try several service features, as we will see in our demo. Using Studio, you can start experimenting with the services and learning what they offer without needing to write any code, so with a low-code approach. And then you can use the available client libraries and REST APIs to really integrate these in your solution, in your own application. But let me move on the interesting stuff, right? Generative AI and
hot right now,
as I say. For vision.
So hot right now.
Yeah, exactly. So as I mentioned at the beginning, I think we talk a lot about language models, large foundation models in general in the natural language processing domain. And it's fair because, I mean, they have reached and unlocked capabilities in that domain, reaching parity for some of the tasks in the natural language processing, like Q&A. So I totally understand the hype about natural language processing, but I want to stress out that large foundation model enhance also the computer vision domain. Because lots of tasks we mentioned it, Corey and myself mentioned it before, can be addressed by machine learning models developed with a traditional approach, which means machine learning models trained for a specific task with domain-specific data. For example, to be able to build a classifier that categorize images among different classes, we could train a model using a supervised data set made up of pairs of images and labels, like the old school, we could say. However, the future of AI, or the present of AI, are large foundation models that are flexible, reusable, and that can be applied to just about any domain or industry task. And these models have been foundation models are at the heart of many of the latest breakthrough, and these models have been influential in the development of artificial intelligence systems and have played a major role in changing how AI systems are constructed since their introduction. A foundation model is a machine learning model that is trained on a large amount of unlabeled data from diverse sources like books, articles, websites, allowing it to be adapted to a wide variety of tasks and respond with facts. with facts, with grammatically correct text, in case of computer vision, with a sample of images, and also semblance of creativity. So these models capture general patterns and structure of data, and then aim to replace task-specific models by unifying different tasks and modalities into one. So eliminating the need to train individual models and integrate several models together. I think one of the most common application of large foundation models in computer vision is demonstrated by DALL-E, right, Corey?
For sure, very exciting. Have you seen DALL-E 3? Especially in the Bing image creator. Let me know in the chat as well if who has used the new like Bing image creator. It's amazing, powered by DALL-E 3. But I really like it because, I mean, now that like that slide that you had was perfect, and Orlando has also said great simplified slide. So I agree, because if you look at the I guess a wave of AI and the not necessarily hype, but the excitement around all of the things. Like first we kind of had general like classification stuff, and that was kind of cool. And then we're like, well, computer vision came with classification of images, but then we're like, let's put it in self-driving cars, right? And then like that was like what we wanted to do, right? Was all of this, like that's how it was kind of powering things. And then now the large language models are coming, and that's really hyping NLP up. But then if you look at combining those things, right, it's the solutions that we have and the things that we can put in the applications are just amazing now. One thing about the actual service that we're talking about, Robopix, I don't know why I try to say people's usernames. It's a losing game, but Robopix, I'm gonna go with that one. Is custom vision part of the Azure AI Vision service?
Good point. So custom vision, what I called Azure AI Vision is basically what was called Azure Computer Vision. So you might be more familiar with this name, Azure Computer Vision. Azure Custom Vision is another service. Historically, Azure Computer Vision offered pre-trained models that you can use directly as they are in your application, while the custom vision service enabled you to train also custom models on your data. Now there's not really this big difference between the two, because now Azure AI Vision also enable you to customize your models. But we still have the custom vision model, because the Azure AI Vision image analysis, the latest version of the API, of the image analysis API that enables you to customize the models, is in preview and also available in a limited set of regions. So that's why we still have custom vision. We still keep custom vision, but I would say that the future of vision on Azure is definitely Azure AI Vision.
Nice. That's good. Very clear.
Awesome. So for those of you who were talking about DALL-E, but for those of you who are like hearing DALL-E for the first time, I just wanted to have this slide to show you what's the output of those models. So they basically are able to translate a natural language processing prompt, so an input written in English, for example, in the examples here in the slide, into an image, original image generated by the model from scratch. And here you can find some funny examples. And as Corey, and this is available on Azure OpenAI service. While as Corey was mentioning, the next generation of DALL-E 2, which is DALL-E 3, is now powering Bing Image Creator. So if you want to test it, you can test it directly on Bing. And the cool thing is that it delivers significant improvement to DALL-E 2 on the same prompts in terms of caption fidelity and also image quality, along with additional mitigation for harmful content generation risks. So I would encourage you all to test it out.
Yeah. Valentina has tested it out. She says there still needs some improvement. I think that's it says about almost every model ever. But extra limbs appear from time to time. But if you don't call them extra limbs, or you call them bonus limbs, then hey, it's okay, right? Like I think, yeah, these limbs, the fingers, the things like that, I think the models are just continue to struggle. But I think what I've seen, especially around the prompting of these, if you like give it the prompt around like zoomed in shot or single person, I think it definitely performs much better than once it's like multiple people. And I don't know the science behind it, other than it has to generate more limbs, more people, and things like that. But like individual people and zoom shots seem to be really working well. But you know, it's all the power of prompting too to get the things where you want them.
Yeah, absolutely. Good point. And that's why it exists. Like it has been created a whole discipline, we can say, which is prompt engineering, right? Because it seems easy, right? Because you just need to write in English an input to the model, but sometimes it's not so easy. In particular, with image, you really need to design your prompt in a way to get the output as close as possible to what you are expecting, and sometimes it's not so easy as it could seem.
Yeah, for sure. And I think what I've been seeing is like even as the models get more advanced, like we also need to kind of advance the prompts in a way. So like in DALL-E 2, there was like a distinct kind of style. And then in DALL-E 3, if you want that style, you have to almost specify it. Like you need to like cinematic style or something in your prompt just to get that kind of feeling, because it, like you can see, it's sort of generating its own kind of style, if you will, for a model that has it. So it's like I think we also need to like up our game a bit to get that, you know, again, the right things that we want. But yeah, prompt engineering, I think we'll have a session on that. So small little ad there for another session on prompt engineering.
Awesome. So coming back to generative AI in computer vision, image generation is just one of the possibilities of using generative AI in computer vision, right? But today I wanted to introduce you to the Microsoft Florence foundation model, which is also a large foundation model like DALL-E. Developed by Microsoft Research and trained on billions of text images pairs. By using universal visual language representations in the form of text image pair data, this model can be easily adapted to various computer vision tasks, such as classification, retrieval, object detection, and captioning. And Florence significantly improves the vision image analysis capabilities, whose latest version is in preview, as I mentioned before, and it's called Image Analysis version 4.0. So if you see in the doc mentioned Image Analysis version 4, this is the one powered by the Microsoft Florence foundation models. As I also, just to clarify again, before the Florence Foundation models development, Microsoft Custom Vision Service was the one which enables model training, model customization using a minimum of 15 images. Now with Florence, users can train custom models using an even smaller minimum of 4 images, because it basically leverages the few shot capabilities of large foundation models. And talking about Florence again, let's have an overview of the use cases, like the most common use cases we can use large foundation models, because we are going to put this in practice, but of course we cannot demo every capabilities of this model, otherwise we would need probably the whole day. But just to give you an overview of the possibilities in a way that you can also find out your scenario, your specific scenario. Definitely you can do image captions, for example. They are accessible through the caption and then captions features of Image Analysis 4. And both features use the latest groundbreaking Florence-based AI models to analyze an image, to understand and generate a human-readable sentence or a multiple sentence describing the image content. Then we have the newest image retrieval features, which is very cool because it overcomes the traditional retrieval approach technique of using labels and tags, descriptor manually or automatically assigned to the image, and relies on the more efficient technique of vectorization. So vectorization converts images to coordinates in a multidimensional vector space, as we have seen at the beginning with the visual of the image and all the pixel. So image retrieval empowers basically developers with the capability to search images using natural language queries. So again, you interact with the model in English basically, and you can retrieve with the natural language quiz the frame of a video or a specific image we are looking for. Then another cool feature, for example, is background removal, which is possible thanks to the image analysis version 4 API, which is capable of splitting an image into multiple segments or regions to identify different objects or parts of the image. We have video search and summarization, which uses a combination of natural language processing and computer vision techniques to analyze the content of a video. We have, for example, talking about retail scenarios, we have the product recognition APIs, which is brand new as well. It lets you analyze photos of shelves in a retail store and detect the presence of products as well as gaps into shelves with the coordinates. And in some cases, pre-trained computer vision models may not provide the accuracy or precision necessary to produce the desired results. And that's where we use model customization with few shot fine-tuning, as we were talking with Florence. So this is an overview of what is possible with image analysis 4. We are going to see some of those in action in a minute, basically. And let me move to the exercise part at this point. Let's do AI, right? As we
so yes,
at the beginning.
we hit the 30-minute mark. I'm sure someone's like, they were saying they're going to do AI and they just been talking AI. We're doing AI now. Okay, so I actually am trying to solve a global problem. I'm building a startup, Carlota, okay? And it's going to tackle the problem of food waste. Like, I got a family of 4, and sometimes we overbuy food. Things, they go in the back of the fridge, and I know it's there, but I'm like, I'm not going to grab it. Or even if you don't have a whole family, right? Food waste is a huge problem. Just go to your refrigerator after this. Don't leave now, but go to your refrigerator after this, and you'll probably see something expiring, something you could have used. Like, I know we can all admit it, right? So my startup is going to solve that problem. So if anyone in the chat wants to invest, just let me know. But Carlota, I want you. I need to use this AI thing to get this solution off the ground. So how can we do that?
Yeah, I'm happy to help you on that, Corey. This is a great mission. So just to recap, if my understanding is correct, your startup basically want to implement a solution able to recognize fruits in the fridge and then notify the end users through, for example, a mobile app about its content. This way, the user, if they are outside and they can know exactly what they have in the fridge at their homes and what they should not buy, what they should not buy to avoid food wasting, right?
Perfect. Yeah. And fruits. Yeah. That it all connects now, right?
Yeah, exactly. So let me start focusing on the AI core part of the solution, right? So basically, to solve this problem, we certainly need a computer vision model able to identify those fruits in the fridge, right? And I'm guessing that probably, Corey, your startup heard about Azure AI Vision service, but doesn't really know like each feature, what each feature does, right? I'm guessing, right?
Yeah, we got some great credits from the Founders Hub, and yeah, but we don't know how to use them. We don't know what to get started. So Carlota, we've hired you to tell us what to do.
Awesome. I'm here for that. So my first recommendation would be to kick off with Azure Vision Studio, which is the newest tool providing a unified portal experience on the browser for exploring and testing several functionalities from image analysis 4, using a set of UI-based components. And you can also experiment on your data. So I think this is very, really the starting point if you want to experiment with different features. for everyone here, if you'd like to follow along with the exercise, for this first part of the exercise, you will need an Azure subscription, and you can claim a free trial, even either if you are a student or a professional. You can use these links in the slide to claim your free trial. So once you create your Azure subscription, then you need to have a cognitive services multi-account resource. So you can do this to you just need these prerequisites.
Yeah, we're not here to listen to AI either. We're here to do AI. So if we also have a collection that I think will be also shared that kind of follows along with what Carlota is going to show you. So you can do this at home once you create an account as well.
Yes, perfect. So let's go to the Azure portal, right, to make things more hands-on. So this is my computer vision resource, or better, my Azure AI Services multi-service account resource. I need a multi-service account resource in this case because I need to assign these to my my Azure AI Vision Studio. Also note that I deploy these in East US region, since some of the features we are going to try out have region limitations. And again, please consult the whole list of region availabilities in the official doc before deploying your own resource. And now let's move directly to the Vision Studio. So the studio I introduce you, which is basically the portal offering a graphical user interface to interact with the different capabilities of computer vision models. And the first thing that we should check here when you enter the Vision Studio is that your Vision Studio is, you have your Azure AI service resource selected as default resource in your Vision Studio, in a way that you are sure you are using your resource when you try out the different features, basically. Now we are ready to explore Vision Service features. And let me start from the caption feature we mentioned before. So captions feature is designed to provide, let's recall, is designed to provide a short description in natural language of the content of the picture. For example, let me try out a picture here. We are talking about fruits, right? We are in a scenario for a startup that is trying to avoid food wasting, and is trying to recognize fruits in fridges. So let's try directly on a picture. And here's the output. Basically, what I get here is a reply in a JSON format in which I have a text, which is a description of this image, a banana and an orange on a white surface. And then I also get the confidence score of the model for this prediction. So, Corey, what do you think? I think this is already a quite good result for your setup, right?
Carlota, you're a nice person, but I think he's missing something. I don't know. An apple, maybe. I'm seeing an apple there. I'm not seeing the apple in your description. That's going to be a huge problem for the startup. The startup world is cutthroat, so it's really hard. We got to make sure our product is good.
Let's
go back to the drawing board. Let's go back to the drawing board on this one.
Okay. Yeah, you're right. I mean, the caption feature is great if you want like a short description, an overall description of the image you are putting in input. But maybe for our use case, since we really want to catch everything in every part of the image, could not be ideal. So let's go back and look for like another feature that could be more suitable for our scenario, right? Let me try with the dense caption feature, because I want to see the difference between the two feature. And let me upload again the same image. Or here we are, right? We have our banana, our apple right now. So we have, differently from the caption feature, we have multiple human readable captions for an image. The first one, which is the same we got earlier, that described the whole picture. And then we have several sentences, each one covering the central object detected in a portion of the picture. And we get a more comprehensive description because each detected object includes also a